deal with implicit function. There are two kinds of function. One is called explicit function and other is called implicit function. In an explicit function, you can keep one of the variable, either dependent variable or independent variable. We always denote x as the independent variable and y as the dependent variable. Most of the time, that is a standard notation we are using. If we are able to write y alone on one side and all the x terms on the other side, we call it as explicit function. Suppose I cannot split in this particular function, x and y are mixed, and it is difficult for me to make y as a function of x. It's difficult for me to make it in this format. All the y on one side, x on all the x term on one side, and y alone on the other side. This is called explicit, and this is called implicit, where x and y are mixed are called implicit function. In such function, how will we find out dy by dx? That's what we are going to learn today. For example, we have learned the pair of lines equation. I'll take this as my first example. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. You know that a, h, b, g, f, c are all numbers. There are only two variables in it, x and y. And you are asked to find what is dy by dx. If a function is given to you in this manner, and from this, we want to find out what is dy by dx. Such a function is called implicit function. In an implicit function, how will you find out the derivative? That's what we are learning. First, what you have to do is write the equation as it is, however it is given. No need to make it right-hand side 0. You can keep the way they give you the function, like that will you keep it. Then directly differentiate with respect to x. Remember, a, 2h, b, 2g, 2f, c, all are constants. So you are differentiating with respect to x. So I can write this for d by dx of ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to d by dx of 0. So I'm differentiating both the side. Now what I'll do is equal to sign only on one side. Don't put equal to sign here. You may put implies, or that is a into derivative of x square plus 2x into derivative of xy plus b into derivative of y square plus 2g into derivative of x plus 2f into derivative of y plus derivative of c equal to derivative of 0 is 0 only. Now we'll differentiate it. A into 2x. 2x into derivative of xy. How will you find derivative of xy? Applying product rule. X into derivative of y plus y into derivative of x. UV rule. X into derivative of y. Derivative of y with respect to x is dy by dx. Y into derivative of x is 1. Plus b into derivative of y square with respect to what? X. They are both are different. So 2y into derivative of y. Very important here. So when you are differentiating y square with respect to x, it is the formula for derivative of u square. Well, how do you differentiate u square with respect to x? 2u into derivative of u. So even if it is y, the formula remains the same. That's why you get derivative of y square as 2y into derivative of y. In other words, whenever you differentiate a y term, you will have a dy by dx with it. So I can write now 2g into derivative of x with respect to x 1. 2f into derivative of y with respect to x is dy by dx. Derivative of a constant 0. So equal to 0. So what I notice is everywhere there is a 2. So I'll divide both side by 2. I divided both sides with the 2, so 2 will get cancelled. Any common term like this is there, you can cancel it off because right hand side is 0. If right hand side is not 0, we cannot do that. Now you will identify how many terms have dy by dx. Here there's 1 dy by dx, here there's 1 dy by dx, here there's 1 dy by dx. So I will take all dy by dx term together and term without dy by dx on the other side. Very important step. There is opening of bracket involved in it. So dy by dx coefficient is h into x. Dy by dx coefficient is by. Dy by dx coefficient is f. Now term without dy by dx, ax, then hy, then g. Remember, when I transferred all of them, they all became negative, so I took minus common. Hence, dy by dx is equal to minus ax plus hy plus g divided by hx plus by plus f. This is the derivative of this function. You have noticed that when I'm differentiating an implicit function, your answer also can turn up to be an implicit function. You need to leave the answer over there. So what are the steps involved in an implicit function? First step, differentiate the function as it is given. Second step, whenever there is a derivative of y involved, it will be followed with a dy by dx. For example, sine of x plus y. If I'm differentiating sine of x plus y, what you should notice? Sine will change to cos of x plus y into derivative of x plus y. So what will be your answer? Cos of x plus y. Now very, very important, the bracket. 1 plus dy by dx. So derivative of x will be 1, derivative of y will be dy by dx. Let's look at another one. Derivative of cos of xy. What will be your answer? Cos will change to minus sine xy into derivative of the angle. When you differentiate xy, what do you need to apply? The product rule. Brackets are most dangerous in this type of implicit function. Majority of the students, they do not put the bracket and the whole answer becomes something else. So you have to be very careful. Whenever you are differentiating an angle, derivative of the angle part, if it is having a product rule or a division rule or a multiplication or any other rule, addition, subtraction, you need to put the bracket. Product rule, x into derivative of y plus y into derivative of x. Derivative of x is 1, so you need not write. Same way, derivative of, let's say, e raised to x square plus y square. E raised to x square plus y square. What is your answer? E raised to x square plus y square into derivative of the power, x square plus y square. What will be my answer? E raised to x square plus y square, derivative of x square 2x. Derivative of y square. This is another mistake students do. Y square derivative is not 2y. 2y into derivative of y. Y square, y raised to n. n into y raised to n minus 1 into derivative of the base. When it is x square, only 2x because they both are same. Here they both are different. So dy by dx will come. You need to note this, all three. You have to practice once. Stop the video once, write this once again. And if you have learned this, then derivative becomes easy for you. Now let's look at a function. Everywhere root is there. So first I did with one problem with all powers, x square, x cube, etc. Now I'm taking with the square root. So we need to find out and the dy by dx for this implicit function. As usual, first differentiate with respect to x. So dy by dx of root x plus root xy plus root y equal to dy by dx of 0. Differentiated with respect to x. Now term by term. Dy by dx of root x plus dy by dx of root xy plus dy by dx of root y equal to derivative of 0 is 0 only. So now differential of root x with respect to x, same thing. So 1 by 2 root x. 1 by 2 root xy into derivative of xy. Which rule I'm applying? Derivative of root u. 1 by 2 root u, derivative of u. 1 by 2 root y into derivative of y. What would happen here if I apply the same formula? 1 by 2 root x, 1 by 2 root x into derivative of x would have been. Derivative of x with respect to x is 1. So even if you apply this formula with x, you will get 1 only. So it doesn't create any problem to you. Okay. Now, one more step is the derivative of xy. So 1 by 2 root x, 1 by 2 root xy, derivative of xy, x into derivative of y, plus y into derivative of x. Derivative of x is 1, plus 1 by 2 root y into dy by dx. Which is a common number here? We have a common number 2 here. I cancel off this 2. Actually, what I've done is right hand side is 0. So I have cross multiplied that 2 with 0, took 2 common and cross multiplied. Now I will take all dy by dx term together and term without dy by dx together. So term with the dy by dx, one term over here, one term over here. So I will write like this, dy by dx. Then I'll write it, what are the terms with it? X upon, this 2 got cancelled, x upon root xy. Then here plus 1 by root y is equal to term without root x, negative sign common, 1 by root x plus this multiplied with this, y upon root xy. This would be my answer. Now, I'll take the LCM. What is LCM? Root y is present both the place. So root xy is LCM. X will no change here and a root x will come over here. Same way, root xy is LCM here. Root y will come over here and a y comes over here. So that I kept the LCM both same so that I can cancel off this both. So I can write my final answer. Since I have shorter space, let me write my final answer over here. So dy by dx is equal to minus, what is common here? Root y into 1 plus root y divided by, what is common here? Root x into root x plus 1. So I can write my answer in this way. Root y into 1 plus root y. If you open the bracket, you can see they cut the same term. Root y into 1 is root y. Root y into root y gives you y. Same way here. Denominator, this goes to the denominator. That's why it has come over here. So this becomes my final answer. Even if you keep in same manner, root y plus y upon root x plus x, then also it is fine. It is not necessary to take common. That's up to you. So directly let me start. Differentiate both the side. So this time I'm directly applying the formula. D by dx of x cube plus d by dx of sine of x plus y, xy equal to d by dx of y square minus d by dx of cos of x plus y. I don't have right hand side 0 this time. Well, however it is given, the same way you have to differentiate. No need to make them to one side, etc. So you get 3x square, derivative sine cos xy into derivative of xy. Okay. Try writing this every time, otherwise you may go wrong. Derivative of y square, 2y derivative of y. Derivative of cos plus sine minus of minus plus sine of x plus y into derivative of x plus y. Now 3x square plus cos xy. Now derivative of xy, x into derivative of y plus y into derivative of x. Bracket, very, very important. 2y dy by dx plus sine of x plus y. Again, bracket, very important, 1 plus dy by dx. I know that majority of the students are going to make mistake in this because of the bracket. So whenever your answer is not tallying, first check whether you have put the brackets or not. So that will give you your answer. Okay, now how many terms with the dy by dx? One term here with the dy by dx. Identify all the terms with the dy by dx. Now bring all the term with the dy by dx together. I am supposed to open the bracket, but I am not going to do that way. I am going to write all the terms with the dy by dx here and term without dy by dx over here. This plan you have to do before only. Cos xy into x. Write x first. X cos xy. If you write cos y into x, you will get confused whether x is with angle or not. 2y is on the left side. On the right side, bring it to left, minus 2y. Then this dy by dx coefficient is sine of x plus y, but you are bringing to this side. So sine of x plus y. Check once again. Cos x into cos xy is positive. 2y dy by dx, 2y will come negative. Sine of x plus y into dy by dx will come negative. So we have got that. Now term without dy by dx. First term, okay, I'll take the positive term first. Here only one term without dy by dx. So sine of x plus y. I wrote the positive term first. Then here 1 minus 3x square. Then this term also is coming to the left. So minus y cos xy. So we have written all the terms. You may count the terms. 1, 2, 3, 4, 5, 6. So total 6 terms are there. Out of that, dy by dx 3 terms on the left and the term without dy by dx on the right. So dy by dx is equal to, write your answer as it is, sine of x plus y minus 3x square minus y cos xy whole divided by x cos xy minus 2y minus sine of x plus y. And that is your final answer. This is how you need to find. Very simple it is. Directly differentiate once, bring all dy by dx to one side, term without dy by dx on the other side. When you differentiate, if y is there, dy by dx will follow by it. Then if it's x term, direct derivative. Then in x into y, uv method. X plus y, u plus v method. So if you know this much, all the problems can be done. Now let's have a look at this. What you notice is base has got x and power has y. It is like base and power have functions of x. So how did we differentiate x raised to sine x? The method of differentiating x raised to sine x was by taking log. The same way, in this problem also, we need to take log. But we don't have to write y equal to. You must have noticed in this problem, there's no, already it is an equation. We don't have to write y equal to and make it an equation. That is done only for explicit function. For implicit function, directly take log as it is given. So log of x raised to y is log of x square plus y square. So y log x is equal to log of x square plus y square. We do not have any property with plus sign, so we'll have to keep it like that only. Now let's differentiate this. So d by dx of y log x is equal to d by dx of log of x square plus y square. When you differentiate this, product rule, y into derivative of log x plus log x into derivative of y dy by dx is equal to log u derivative. What is derivative of log u? Log x is 1 by x. Log u is 1 by u into derivative of u. So your answer will become y into 1 by x log x into dy by dx is equal to 1 upon x square plus y square 2x, derivative of x square 2x, 2y dy by dx. Now, we need to bring all dy by dx term together at one side. So dy by dx is together. I need more space, that's why I'll take a little more. Dy by dx coefficient, log x. Dy by dx coefficient, don't write 2y, there's a bracket here. So it will be minus 2y upon x square plus y square is equal to term without dy by dx, 2x upon x square plus y square minus y by x. Now it is up to you whether to take LCM or not to take LCM. If you take LCM, this x square plus y square can be cancelled. So I'm going to take LCM in this problem. So if I take LCM, I'll get x square plus y square into log x minus 2y divided by x square plus y square into dy by dx is equal to, here again, x square plus y square into x. So when you cross multiply, 2x square and minus y into x square plus y square. This x will get cross multiplied, this will go. Now what do you notice? X square plus y square can be cancelled. Now, any further simplification is not possible, so I'll write my answer. So dy by dx is equal to 2x square minus y into x square plus y square divided by this x and this terms, x square plus y square into log x minus 2y. This becomes your final answer. So every time the method remains the same, differentiate it with respect to x. Whenever you differentiate a y term, dy by dx, whenever you differentiate a y term, dy by dx will be there. Bring all dy by dx to one side, make dy by dx as a subject, and that is your answer.